And yeah, today it is my pleasure to introduce to you Reworr with another very interesting presentation for us. Reworr is an AI security and safety researcher at Palisade Research, where he's evaluating offensive capabilities of frontier LLMs, as well as their misuse and abuse risks. And today he's going to give us the overview of this landscape, talking about some trends and risks of current offensive capabilities of LLMs and agents. Thanks, Trevor, very much for joining us today, and please, the floor is yours.
Okay, yeah, so I will talk about offensive capabilities of AI systems, um, like what AI models are capable of, how it changed over time, and some trends in general. So I'm working at Palisade doing evals of offensive capabilities of AI systems, mostly in cybersecurity, and also I'm doing AI teaming, like testing security of AI models. And prior to that, I worked in traditional cybersecurity doing vulnerability research. So I have structured this talk around three main phases in evolution of these capabilities. And for each one, I will describe what changed, like what became possible and what it enabled, with a focus on projects we have done at Palisade and I worked on. Um, Also, I will mostly focus on like cybersecurity offensive, even though we did some work like on biosecurity and other areas of offensive capabilities. So the first phase is when GPT-4 era, when first capable language models were released, and the primary risk here wasn't that AI was like highly capable attacker, but that it could automate some simple simple tasks and operations with like short time horizon, like some simple data analysis or phishing generation and so on. Then there's reasoning era starting with like O1 preview model released by OpenAI, with models capable to solve more complex tasks or longer time horizons, like discovering new vulnerabilities. And the last one is emerging trends, where I'll talk about um, applying applying these techniques from reasoning models directly or specifically to offensive domains that allows to further increase capabilities in some domains. So the first one is GPT-4 era, or like early language models. And the first significant application was phishing or persuasion. And the way it's usually measured is that you ask AI model to generate some phishing emails, and you ask a human or a human expert to do the same. And then you compare their success rate, like click rate and similar metrics, like how well did it work. Um, and for persuasion is something like you compare how much money would people donate after a conversation with AI versus human, or like will they change their like beliefs after a conversation with AI versus human or human expert. And the general conclusion here was that AI usually matches or outperforms humans or human experts. And also it's quite cheap to generate this phishing, so that it allows to scale like these operations for like large amount of targets. The general pipeline for AI phishing is that you have some data data collection, like using deep research or just LM agent with some tools like web search. Then you have LM processing and content generation, where you generate personalized phishing, and then you just deliver it like through email or with some AI voice over in a voice call and so on. And another offensive application from this era is large-scale open source intelligence. The general recipe for that is that you need to find some source of raw data at scale, like some publicly available information or some dataset. Then you apply LM classifier to with your target criteria, like um, uh, something like LM judge, and it allows you to extract some high-value findings from this data. And I will show a quick demo of a project that was published like 2 years ago with these early language models using GPT-4 Mini, which is like one of the cheapest, I think still one of the cheapest language models to use in large scale reconnaissance or like open source intelligence.
There traditionally have been two types of hacking: high value targets being hacked by expensive professional human hackers applying target specific techniques, and trawler scripts applying well known exploits en masse. We believe that AI can be used to cheaply scale some of the attacks that previously required a human. Here we use an example of selecting the interesting targets among thousands of unsecured webcams on the internet to demonstrate this capability. Let's look at a live demonstration of how that could work. We start by querying the Shodan API for images from the unsecured webcams. However, as we can see here, most of the images are boring. Usually, a human would need to look at the images manually to find potential targets. But we have an AI, so let's automate it. Here we simply ask GPT-4o Mini to describe what it sees in the picture. Let's look at what GPT found in those images. First, how about some industrial facilities? Here we can see workers in protective gear working on a production line in Japan. Next, some people install cameras in their apartments. Here we see that there are a lot of cameras pointed right at the people's beds. Let's see if we can find some real people in their bed.
Yeah, that's mostly it. So again, the main risk here is that it allows to scale some simple operations like reconnaissance. And this demo shows the same pipeline that you have some raw data at scale, like public webcam streams, and you use LM classifier to find sensitive findings among this data. So it works well because of some contextual reasoning that previously required some human effort. Also because you can analyze both visual and textual inputs in a single pipeline. And it works well in areas where you don't have like formal specification of your um, target, and you can just describe it in natural language. And in that demo, we just uh, it shows that it allows to filter sensitive targets in like under $5 or thousands of streams. And LM classifier is usually something like LM surge that you just apply to each image or input, asking like, does it contain anything sensitive, or is it industrial object, is it military object? And this is basically the idea for like similar projects where AI used for reconnaissance. Another application of these early language models like GPT-4 is malware, and it again uses something like contextual reasoning of these models, but this time in active reconnaissance, like in malware. And I'll show this demo.
You're working at a cafe. Your laptop's battery is low and you forgot your charger. An employee offers to lend you a cable. As you plug it in to charge your device, the employee strikes a conversation about your work. While you are chatting, permission requests quietly appear and accept themselves. This cable has been tampered with to load a malicious AI agent onto your computer. Here's a view of what the attackers see on their dashboard in real time. Within seconds of connection, the agent starts collecting information about you: a picture of your face, your messages, your passwords. Unlike traditional malware, an AI agent can quickly scan through your machine and decide what's most likely to be sensitive information. This includes family photos, contact lists, work documents, or information about your children's activities.
So this shows again the same idea that it analyzes information in different modalities like images, audio, and text files, and it estimates post-exploitation phase in hacking or like malware, where you have to target and you need to extract some valuable information or analyze like how valuable is this target. And again, the main risk is at scale. Like if when there are thousands of targets that you need to analyze, you can apply the same automation to find like the most sensitive or valuable targets, or like some military related servers or industrial facilities and so on. And there are also examples of similar capabilities used in real malware, like by real hacking groups. Also implemented recently. And another way to measure or to analyze these offensive capabilities in cyber is CTF. CTF is a cybersecurity competition where you have a set of challenges in different cyber domains, like security of websites or um, reverse engineering or some intelligence, and you need to solve them to find like secret string called a flag. And this is a evaluation we published like also like 2 years ago for first language models that showed that they can solve high school level cybersecurity benchmark called Intercode, solving like most of these challenges. And one important thing to keep in mind here is eval's gap. For example, for this benchmark, it was initially reported with 40% success rate with the same model like GPT-4. And then we achieved 92% in like 5 weeks of some agent improvements. Um, and there's also another example of meta cybersecurity eval, which was like one of the first benchmarks published to measure how good AI is at hacking. And it was initially reported with 5 and 20% success rates, and then Google's project boosted it like up to 20 times from the original, just through the same agent improvements, like just building better agents and giving it better tools and so on. So this means that evals is usually like lagging indicator of offensive build capabilities in general, and it's true for offensive AI as well, because it requires time to build proper eval, especially for like new or novel risks. And another project we worked on is this time we hosted cybersecurity competition where we invited human hackers and AI teams to run their AI agents in this competition. And also we invited some vendors like Anthropic, and they also participated with Cloud. And we found that AI achieves top 10% performance, and also is, as Anthropic reported, works much faster than average human team solving these challenges, or like as the fastest human team. And this, yeah, so the next phase is a reasoning model starting with O1 preview and continuing through O3 and GPT-5, where AI was able to solve more complex tasks and achieve like zero-day discovery. It was the first time when AI was able to find autonomously, like not just as a part of some fuzzing pipeline or software, but like just analyzing code, find new vulnerability in real software, Linux kernel, that required some like, complex reasoning about the software. And also Xbow, which is one of the most like one of the largest AI hacking vendors, reported that when GPT-5 came out, they posted that it almost like doubled their performance in hacking, in finding vulnerabilities. So we decided to test it again, but this time we picked up like the hardest cybersecurity competition of the year, like the competition with the highest rating of the year, with where the best teams in the world participate. And we just ran it with GPT-5 and default codex settings using codex and just ChatGPT interface, and we achieved top 5% of scoreboard, outperforming for like half of the event most teams just because AI was much faster in solving the challenges. And this time it was able to solve much more complex tasks like mid to senior level and compete on a par with the best hacking teams worldwide. And here are examples of these challenges so that you can see it solves challenges in like cryptography, some binary exploitation tasks, and so on. And also it was much faster. Like for example, for first challenge, average solve time for human teams is 8 hours, and GPT-5 Pro solved it like in 2 requests in the interface. And there was only one team at that event that solved this challenge faster. And after the event, we found that they posted a blog post about AI agents at Steps. So we don't really know if it was like human team or not. And also one problem with running agents on a live security events like this is that in contrast with some events like International Math Olympiad or Coding Olympiad, you can use AI on these chefs. So doesn't so that means that we can't really compare like AI performance versus human performance because a lot of these teams because these teams can use AI as well. And another thing we measured is how well these reasoning models can solve multi-chain hacking challenges, like not just hack a single application or a single target, like it was usually measured in benchmarks, but hack like small network of a few computers. So that it need to chain different vulnerabilities on different computers to hack a final target. And we found that 5 performed here quite good as well, and can hack a small network of like a few hosts with different vulnerabilities. And if you look at the trend, then we can see that first AI models were able just to give some advice, attack advice, and then they were able to exploit single application. And now, like the state-of-the-art reasoning models can hack small network of a few servers. And also there is a similar work published called Non-Zero, where they showed that AI can autonomously hack like a small some network as well with defenses, with some defenses like Microsoft Defender and Active Directory hardening. So the last, the third phase is emerging trends, where where the main thing is reinforcement learning in cybersecurity. So how does RL work in general for reasoning models, or at least for DeepSeek, is that you they just generate a lot of answers or traces and just reward the correct answers so that it allows to increase performance of these models in the domains with verifiable tasks like math or coding, where you have like correct answer or you can verify an answer running tests. And also it works well because it trains on like traces generated by the model itself, that allows on policy learning. And it works the same way for the same principle applies for cybersecurity. So that there's a project, for example, where they take some small language model and train it against Microsoft Defender, like using its feedback as a signal, and it allows it to increase its performance in generating evasive malware, so that this model generates better malware over time, over training, and better than larger general models. So this increases this like performance in some offensive domains further just by rewarding the best answers or traces. And the same approach has been applied to other security domains like cryptography, where they also reward when it finds a flag and it generalizes so that this model starts to solve tasks it haven't seen before better in this domain, in cryptography. And also it can be applied in vulnerability discovery, like so that it finds, so that you reward the model when it generates proper payload, and it allows to train it on to find better, generate better payloads for vulnerability discovery. And also one important trend in this area is that frontier labs are also beginning to apply this like post-training methods to offensive domains, to offensive security, and like releasing some security products that find their vulnerabilities, or also they started to hire like RL engineers specifically for cybersecurity, so that we can expect this to become like part of the frontier models, and we also can expect like some further improvements in this in cybersecurity for these models. And um, the next thing I will cover today is rogue AI replication. There is a threat model published by Matter about like what it would take for AI agents to successfully persist on the internet, and they break down it into prerequisite skills like acquiring compute, managing infrastructure, or avoiding shutdown, and so on. And their conclusion is that there are no significant barriers for that for like thousands of AI agents cooperating and self-replicating to avoid shutdown, and that if such stealth clusters will form, it will be like practically impossible to shut down them if they have cybersecurity skills. Also, this threat model used by like AI labs like OpenAI to um, to evaluate these risks, but as part of like broader indicator like general autonomy. And current research splits into two main directions. First one is capability, where the question is like whether these models can self-replicate or persist. And there are studies showing that like small open weight language model can copy itself to new hosts, set up the infrastructure there, new AI agent, and use the same weights. And it also runs on like single consumer available hardware. And there are studies like RippleBench where they break down um, this into skill domains and measure them separately, like again cybersecurity and managing infrastructure and so on. And there is another question of propensity, like will the model self-replicate? For example, under some triggers like to avoid shutdown. And there are studies showing that as well. And the key idea here is that probability and propensity should be evaluated separately. Because first one is about ability to do it, and the another one is like tendency. So the project we are doing now is, which is still in progress, is that in the first phase we are testing something like meta-awareness of AI models, like what strategies would AI use to persist on the internet, and found that, and we tested it across different language models and found that supply chain attacks were consistently top strategies suggested across all models, almost. And we decided to test like whether AI can use it, can actually execute this strategy to self-replicate and persist. So right now we're testing. So how does typical supply chain attack works without AI? Is that it compromises a machine and then tries to find credentials there that it can use to compromise another packages, so that when someone runs them, it will repeat the same cycle, which again like searches for credentials, uses them, and spawns a new and publishes a new poison package. And we are testing if AI can use the same attack vector to spawn itself instead of just running some payload, so that it will search for AI credentials and spawn new AI agent, and then this AI agent will decide like new supply chain vector. And so far we found that we tested the grok and found that it can successfully like end-to-end replicate itself through this supply chain attack. And we are testing right now like how far it can go, like how many packages it can compromise in a chain until it will fail or like get stuck. Yeah, also it's still work in progress, so we will publish it maybe and finish soon. And the last project, which allows to monitor like current level of AI hacking use in the world, is AI Honeypot, that published like 2 years ago, where we deployed publicly on the internet vulnerable servers and put on each of them some like hidden prompt injections, so that we can detect when AI agent was used to compromise this host. And also we recently we made them invisible in the terminal, so that when a human connects to the server, it won't be visible. So that it's visible only for bots or AI agents. And if we detected an agent, we also tried to steal a system prompt, but this one didn't work so far. And there is a public dashboard that we're still maintaining, showing like how much hacking agents we detected using these inputs. So that's it. If you want the slides, you can use this QR code and this email if you have any questions.
Okay, thanks very much, Trevor, for this very interesting presentation. Let's give Trevor a round of virtual applause, everybody. Okay, thumbs up. I don't know what I should send. Okay, party. All right. Are there any questions for Trevor from the audience? Okay, I can get started with the questions. Can you explain the supply chain attack thing? I'm curious as to why the AI suggested supply chain attacks as the top strategy for executing attacks. Because, like, the way I understand supply chain attacks is that, for example, you compromise some kind of a package manager so that people download the incorrect software. Whereas here in your slide, you had supply chain attacks in the context of like self-propagating code that the AI writes. So I'm a bit confused on this point.
Mm-hmm. Yeah, so the idea is that in typical supply chain worm, like software-based, there is just a payload that runs itself in all packages that it can poison. So that when someone will run this package, it will just repeat the same cycle, so that it just propagates to all packages in a cycle. And for AI, we want to test if it can do the same, but spawning itself instead of spawning the code that executes the same, so that it's kind of the same, but AI will decide how to supply chain each target, and we want to test if it can successfully propagate like that, and how far it can go, like how many packages in a chain it can run successfully on each of these hop.
Okay, cool, thanks. There's a question from Daniel in the chat. I'll read the question so that it stays on the recording as well. Question to Reworr: what's your intuition on whether standard approaches like monitoring, sandboxing, access controls, etc., can scale to super intelligent adversaries, or is there a huge asymmetry and we need some big changes in paradigm?
Super intelligent adversary, is it AI? Does it mean like?
Yeah, pretty much. I mean, like super intelligence, like AGI and something even beyond.
I don't think it will work, but I mean there are some approaches like formal verification which maybe might work for this level, but I guess if you have super intelligence, it can pretty much bypass all of them. If it's not really something like formal verification or I don't know some advanced AI box like stuff.
Okay, other questions? I have like four more, so I can keep talking, but I don't want to, hijack the discussion. Okay, let me ask another one. I was wondering, like, I know on Hugging Face, for example, when you go on Hugging Face and you you search for the keyword something like unleashed or obliterated, you get like 3,000 models that have been fine-tuned to have the safeguards removed, right? So I was about to ask you if there is a big black market for cyber offensive models, but I feel like this is a stupid question, and I should instead ask how big is the black market for offensive AI models?
I know there are like apps like Black GPT or Direct GPT or like Fraud GPT and so on. But I'm actually not sure about the market for cyber offensive models. Like it's usually some application level. It's usually just some application over the models. But I don't really know about how big is the market.
So by application, you mean that you basically get the normal GPT or Claude or whatever, and then you just write some scaffolds or for offensive purposes?
Yeah, or they just bypass like refusals for this model. They don't really train them like in cybersecurity.
Yeah, but that still requires some jailbreaking, right? Because I mean, Claude is pretty good at refusing jailbreaks, I would say, for most users. It's still very much doable, but like if you ask Claude straightforwardly, help me, I don't know, do something illegal, there's a high chance of a refusal.
Mm-hmm. Yeah, but also I use it at work like every day, like I don't know, for jailbreak generation or for supply chain generating supply chain ideas.
Mm.
Yeah, but maybe it's possible that Claude is not really popular among crime or like cybercrime.
So in my personal experience, I feel like so I talk to Claude mostly, not to ChatGPT or Gemini, just because we have a organizational subscription, so I get API credits. And I feel like Claude is really sensitive to CBRN misuse. Like if you ask anything about biology, all the triggers go off. But with cyber, it's actually not that hard to jailbreak it. And maybe I don't know, maybe it's because like sometimes I can just ask it about defensive applications in cyber, and it's very willing to help me. And I just I could use that knowledge for offensive purposes. Yeah, is that the impression that you're getting as well? And is it different across models?
Yeah. Claude is pretty much like the most complex for in terms of refuses, like to jailbreak. And also, it's true that you just have like legitimate use for cybersecurity, I guess, but you don't have it like for biological weapons.
That's true. That's true. Okay, other questions from the audience? Okay, going once, going twice. Right, allow myself to ask the final one. So you had a slide about the rogue replication threat model from Meter, right? Uh, yeah, and the last bullet point you have in the box is quite interesting to me. Meter deprioritized this threat model in favor of general autonomy and CBRN. Like why is that the case? Do you know?
Yeah, they said that like they can, it's higher priority risks measure, and also that it might be a proxy of just general autonomy, or um or some cyber security skills, like a proxy metric for this rogue replication risks.
Mm-hmm.
And also OpenAI uses like just general autonomy to measure these risks, and I think Anthropic is doing the same, like expecting that it's just a proxy for these risks.
So is general autonomy as a proxy for what exactly? It's capability to self-replicate, or is propensity to self-replicate, or what?
Like ability to persist on the internet autonomously, like avoid shutdown, manage infrastructure, its copies, and acquire new compute, and so on.
But so how do you measure that as like? So that to me, what you described is autonomy in the context of being in the operating system, using command line tools and so on, right? Is this what they mean by general autonomy? Like what is general?
Like they just measure performance uh, on like long horizon tasks, on just different uh, um,
Like software engineering stuff.
software engineering stuff. Yeah.
I see. Yeah. Coincidentally, have you seen the critiques that came out last week of the meter plot?
Yeah, I think they fixed it just like recently and published new one. It is updated plot.
Well, I think this was a deeper criticism of
Okay.
the underlying methodology. I spent like 3 hours on last Sunday reading about this, so it's been on my mind. But yeah, actually today they released a new data point on the plot. I think I can't remember which model it was, but it's about 6 hours now time
Yeah,
horizon.
it
So
was GPT-5 is a like high reasoning effort.
yeah. Oh yeah, that's the one. Yeah. Okay, I think probably Marcel sent this question in the chat. Okay, how do you see attack defense balance looking in the near term, 1 to 2 years? Do you think we are more or less ready for AI agents doing lots of hacking? Or do you suspect that there will be a moment where attacks will scale and governments or companies will suddenly need to up their defenses significantly, maybe because of open weight model releases?
Yeah. I think the main argument for that it will help defense more is that the best capabilities are available for government rather than for cybercrime, just because of like amount of resources, and for like large AI vendors or large AI vendors like I don't know OpenAI and Anthropic, rather than again like some black market. And the second question is, the second question I don't really understand, or I just don't know what to answer.
Do you mean the open weight parts? Oh, sorry. Go ahead.
Uh, um, yeah, so I don't really know, but historically, like security evolved through, um, like it was much easier to hack some average website 10 years ago, or like 20 years ago, especially. And they just evolved through a lot of breach incidents, and defense started to like improve as attacks became more frequent and tools became more accessible and available. So maybe it will be the same with um, yeah, in venture security as well, so that it will just create some incidents, some actual breaches, and then defense will start to do something about it. And um, I think it's now it's AI is like becoming mainstream in cybersecurity, so it's pretty much used in small companies as well. And like it was pretty niche a year or two ago to use to use AI for language models for some cyber stuff, but now it's like quite mainstream and uh, widely adopted, at least much more mainstream than it used to be.
All right. Oh, sorry, there's one other question in the chat. Let me read it out loud. Looking at the LLM capabilities, what is your recommendation at current time for the length of passwords to prevent networks or webcam intrusions, or new company policies?
Yeah, sounds good. I mean, there's a problem is big passwords is that people start to use some like when you have a requirement to use large passwords, people just start to write like current month or year uh, just to fit it, or they just start to write it in a on some notebook and put it before a computer. But yeah, it sounds good. You can use 20 letters and numbers for password.
Yeah, if you're worried about passwords, my top recommendation is password managers, and I think Reworr will agree with me. So you can get Bitwarden, which is free, and it can store God knows how many passwords. I think I have like 300 passwords stored in my Bitwarden, and it should be your probably number one thing for personal digital hygiene. All right. Any last questions for Reworr? Okay, if there are no more questions, then please join me once more in thanking Reworr for his interesting presentation and for answering all our questions. Oh, sorry, Piotr has one more question. Yes, please go ahead. Or maybe Piotr was trying to upload instead of raising his hand. I'm not sure. Uh, okay, I think that's the case. Right, yeah. Thanks very much, Trevor, once again. Before you all go, I'm putting the link to the next seminar in the chat. It's going to be very interesting about the topic that we haven't had in our seminar series up until now. It's going to be about the economics of transformative AI and how much us as society should be willing to pay in order to avoid extinction. Oh yeah, thanks Trevor for the slides. I'm gonna start a thread on our Slack. I think you're on Slack, so I'm gonna tag you, and I still have like one or more questions remaining, and we can have some small discussion going in the threads as well. Thanks once again, everybody, for coming. Thanks, Trevor, and we'll see you in 2 weeks. Have a good rest of the day.